So here's that same schematic, but as a visual. So if I start with a buffered solution of acetic acid and acetate ion, and I add hydroxide in the form of a strong base, then the pH increases. If I add H plus in the form of a strong acid, then the pH decreases. We determine how the neutralization reaction affects the amounts of the weak acid and its conjugate base first. That's a stoichiometry problem, just calculating the new amounts. Then we use the Henderson-Hasselbalch equation to determine the new pH of the solution once we know the new concentrations of base and acid, and we're given our Ka value. Each buffered system has a pH range, which is the range of pH values over which the buffer system works effectively. It's best to choose an acid with a pKa that is close to the desired pH. Once we do the next section on titration graphs, you'll see why buffers work best when the pKa is close to the desired pH. All right, let's walk through a problem-solving strategy for how we'll calculate pH changes in buffers. The first phase is the neutralization part, where we use our stoichiometric calculations. So we identify the added substance, identify the component of the buffer that will neutralize that added substance. Then write down the equation for the neutralization and solve for the new concentration of the buffer components. After that, write the relevant dissociation equation, create the ice chart like we do with equilibrium with new concentration values that you calculated in step 1 of acid and base components of the buffer, and then use the Henderson-Hasselbalch equation to solve for pH. When doing buffer calculations, typically you're asked to calculate one or more of the following. First, we'll address calculating the pH of the buffer alone in sample problem 6. Then we'll calculate the pH of the buffer after a small amount of a strong base has been added and neutralized in sample problem 7. And finally, we'll calculate the pH of the buffer after a small amount of acid has been added and neutralized in sample problem 8. Because it's a buffered system, the pH will not change drastically, usually less than a factor of 1 on the pH scale.